Hello everybody, and this is Great Math 17 with me. Alright, you saw in the last video that I actually tried to figure out the basics of advanced inequalities. Now this is gone to a more interesting complex. This. Well, it's going to be hard to evaluate the whole thing, but it's going to be pretty easy. I'll show you why in a sec. Well, here's one tip, two tips to math. First of all, think math is easy. And second tip, if you can't compute a whole big equation at a time, start with small steps and then compare them. Like this, we're going to do. And then we're going to do this. We're going to start with 7 plus x is greater than or equal to 2x plus 3. And we'll place the variable to one side. No, wait. Yeah. To one side. And then we combine these. And then we have to get rid of the 7. But we're not done yet. We have to multiply this by the reciprocal of -1. And then takes out the negative. So x is less than or equal to 4. The same thing happened over here. But we're also going to have to graph on a number line this time. So, 0, 1, 2, 3, 4. So it's going to be less than and equal to 4. And as I told you in the last video, if it has the less than or equal to 4 or greater than or equal to 4, it means that the number that is greater than or less than is included. So therefore, this is what's going to happen. It's going to include 4, and any number including 4 can work. Then the next part. I'm not going to erase that, and I'm just going to keep this here for the last number line. Next one is going to be more simple. 2x plus 3 is less than 12 minus x.
It's greater.
Greater than 12 minus x. And then I have to add x on each side first. Then 2x plus 3 plus x is greater than 12. Then we have to group the like terms using the commutative property of addition. Then it's 3x plus 3 is is greater than 12. And then subtract 3 from each side. Which means 3x is greater than 9. Now we have to divide them by 3. Then x. Then you get x is greater than 3. So let's graph our number line. 0, 1, 2, 3, -1, -2. Alright, so therefore it's greater than 3. So therefore 3 is not included. And now for our final number line. Alright, this is this. 0, 1, 2, 3, 4, -1, -2, -3, -4. Alright. So therefore it's going to be somewhere between 3 and 4. So therefore, not including 3, and then it ends at 4. That's the result of the first one. And we're going to use the same thing for the next problem. Let me erase all of that. Alright, now our next problem is this. 2x plus 2 divided by x plus 7 is less than or equal to 0. This is a little bit trickier, though. We're going to have to divide this into 2 cases, each using different properties. And they'll do the same result, but the inequality will be flipped for each case. Case 1 questions. 2x plus 2 is greater than 0, and x plus 7 is greater than 0. Case 2 problems. 2x plus 2 is less than 0, and x plus 7 is less than 0. Since we
Why do you have these 2 cases?
We're in the middle of the fraction, and we need to figure out, and we need to graph this on a number line.
No, but why it's positive if you got these 2 cases?
It's positive so that, well, because you don't know if the fraction is going to be positive or negative.
Okay. Because if you have negative on the top or negative on the bottom, what happens?
If you have negative on top and negative on bottom, as I told you in the last video, positive.
Oh, because it's a multiplication, or?
It's in the middle of division.
Okay, I understand. So if the both are different sign, if the top is positive on the bottom negative, that would not work.
Yeah. Same with the top negative and the bottom positive.
Okay.
Yeah, thanks for that point. And anyways, let's solve case 1.
Okay.
Well, because case 2 will probably slightly have the same results, but with the inequality sign flipped.
Yeah, you can erase the square here. Hey, Ethan, you can erase it here. You don't need it anymore.
Yeah, I don't really need it anymore.
Okay, alright.
But anyways, back to this. Anyways, case 1 problem number 1. 2x plus 2 is greater than 0. So first, remove the 2x is greater than -2. So we got that one down. No wait. We have to remove the we have to remove the 2x, then x is greater than -1. Then for this point, -1, 0, 1. At this point, 1 will not be included. Wait, let me try to rewrite that again.
No. 1 would be included because it should be greater or equal. Look,
no.
Here do I have a greater or equal sign, so should I have a greater or equal?
You do have a point there, cameraman.
Actually, but not in the bottom. In the bottom, no. This one cannot be equal to 0, can it? Because it's at the bottom here.
Yeah.
This one is straight.
Well,
is that right?
Yeah, but that one's non-strict.
Okay.
Strict and non-strict are different. This is non-strict.
Okay. So hold on. This one doesn't need to be straight too. This one here.
This one doesn't need to be strict?
Yeah, and this one gotta be strict because it's under. You cannot have 0. You say you cannot have 0
but what
under.
about this?
This one, it's the same thing. Can it be strict? Should it be strict or not?
Yeah.
Can it be equal to 0?
It can't.
Okay, then you're right.
Alright, but now back to the other case problem.
Okay.
X plus 7 is greater than 0. Well, I'm sorry if my greater than signs looks like 7s. But back to the problem. Now first we have to simply remove the 7 and we get our result immediately. See, x is greater than -7. But now here's the thing. Case 2 problems are the same thing.
Do you need to box when you get a result?
Oh.
The both?
Just skip point again. But anyways, to let you know, case 2 problems are the same answer, but the inequality sign is flipped.
Okay.
I repeat, the inequality sign is flipped.
Okay.
So therefore, it's going to have a different result.
Okay.
So therefore, case 1 solutions are positive and case 2 solutions are negative. So now we need to graph it. Now we need to graph it. And in order to satisfy all values of x, we need to take the first solution of case 1 and second solution of case 2, which is the same thing as this, but the inequality sign is flipped. So -1, -2, -3, -4, -5, -6, -7. So therefore, and also these will happen. So therefore, this is what the graph will look like as a solution.
Okay.
So today we learned more inequality problems and trying to use small steps to figure out big equations. Now this is Great Maths, and now this is Great Math with me, Ethan, and that's all, folks.